Good afternoon. Are you able to hear my voice?
Yes, sir. Yes, sir.
Good afternoon. Okay. Let us start today's class. Now, before going to start today's class, we go back to the previous class and we discuss about what we have done in the last class. Then we come to the today's class. In the last class, that is on Friday, we have completed the maxima and minima topic. After completion of maxima minima, we have started the indeterminate forms. The indeterminate forms or meaningless forms. And also we have done the problems on indeterminate forms. That is, we have seen the method of evaluation of limits of the form 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0, and 1 power infinity only. After this, we have started the integral calculus part. In the integral calculus, the first subtopic is, or contains of the topic is, definite integrals. Definite integrals. In the definite integrals, we have seen the condition for writing the value of the integral. When function is continuous in the interval and the integral of the function f of x is possible, then only we can write the value of the integral. That value is given by f of b minus f of a only. Function is continuous and the function is integrable, then only we can have the value of the integral. This value is the definite value of the integral, and we write this as integral a to b f of x dx equal to f of b minus f of a only. Right? Function should be continuous, and also the function should be integrable. That is, integration of the function should be possible only. Then only we can have the value only. Otherwise, not possible only. We cannot write the value of the integral. After this, we have written the properties of definite integrals only. These are the properties. Integral a to b f of x to dx minus b to a. That is, when you change the limits, we get minus sign, or if you have a minus sign, we substitute the lower limit first and then upper limit first later. And if we take some point between a and b, we write the integral as sum of two integrals. If we take 2 points inside the interval, we can write the integral of sum of 3 integrals. Integral a to b f of x dx value is same as integral a to b f of a plus b minus x. Fourth one can be obtained from third one for a equal to 0, b equal to b1, b equal to a. Next, fifth one, minus a to plus a. Whenever the limits are same and opposite sign, then we can check the function is even or odd. Even, we write it 2 times, odd 0. And if you want to write this 0 to a as 0 to a by 2 like this, we check the f of a minus x equal to plus f of x. This condition satisfies, right, 2 times. Equal to minus f of x, directly integral value is 0. Next, inside the integral, when function f of x is multiplied with x, if any function is multiplied with x, then we can write only f of x when the condition satisfies like this for f of x. So extent f of x will be reduced to just f of x with this condition only. Next, property number 8. Integral 0 to pi by 2 sine power n cos power n. Sine power nx dx equal to integral 0 to pi by 2 cos power n dx. For both, integral value is given by like this. That is, using the power n, we can get the value of the integral. In the numerator, we start with the power minus 1. In the denominator, we start with the power minus 0. And then we decrease by 2 only. But the condition is this number n should be more than this. This number n should be more than this. This should not be same as this, should not be less than this, should not be same as this, should not be less than this. It is the condition. Into k value. The k value depends on, again, power. If it is even integer, power pi by 2. If it is odd integer, power 1. Similarly, for the product of two functions, sine power m, cos power n. Like above, we are the same with the same condition. That is m minus 1 and n minus 1 and decrease both by minus 2. In the denominator, sum of the powers minus 1 and decrease by 2 only. Into k value. That depends on the, again, powers. Both m, n are even integers, we are the pi by 2. Otherwise, 1. Otherwise means any one is odd or both are odd. Then we can add 1 in place of k. And these two properties, 8 and 9, these two properties work for positive integer powers only. N should be natural number or positive integer. Here m and n should be natural numbers or positive integers only. These two properties only for positive integer powers. Not for negative numbers, not for fractions, not for negative fraction like this. For fractions and some negative numbers, we have the special functions, beta gamma functions. Next, property number 10, UV formula, integration by parts formula, or integral of product of two functions. According to Eilert, we choose the first and second function from left to right order. E stands for exponential, T stands for trigonometric, A stands for algebraic, L stands for logarithmic, I stands for inverse trigonometric. From left to right, we choose the first and second function, and we use this property or this formula to find the integral of product of two functions. Next, 11th one. 11th one is the generalized integration by parts formula. Generalized integration by parts formula. This is given by u into v suffix 1 minus u dash into v suffix 2 plus u double dash into v suffix 3 and so on. And this is so on means infinite many terms, but here we should have only finite only. That is, this process will stop when the first function is polynomial. Otherwise, it will be continued only. That is why to apply this generalized integration by parts formula, the first function should be polynomial function. Whenever u is polynomial function, let us suppose the x cube. It is a third order polynomial. U equal to x cube. Here x cube, same function. Here first derivative 3x square. Here second derivative. Here third derivative. In the next term, the derivative of constant is 0 only. So this process will stop at this term only, at the fourth term. 1, 2, 3, 4. That's it. Like this. To apply this property or this result, the first function u must be polynomial function only. This is the condition. So this is the 11th property. Next, 12th property. Derivative of integral of f of x is f of x. Next, 13th one. Derivative of integral of f of x dx. Both are just like derivative of integral, but the difference is in the 12th property, no limits of the integral. In the 13th property, we have the integral properties. That is, we have the integral limits only here. In this property, for integral, we have a limits v of x, u of x. And these two are functions of x only, not just constants integral a to b only, not constant limits. It is a function of x, it is a function of x only. So we have a functions of x like this, we use the formula. Integral 0, that is integral a to a f of x dx equal to 0. Upper limit, lower limits are same, then integral value is 0 directly. That's it. These are the properties only. Up to here, last class. Now we start the today's class. That is, we do the problems on this topic, different integrals only. Okay, let us start the problems on this. Problem number 1. The value of the integral minus pi by 2 to pi sine of mod x dx is the value of the integral minus pi by 2 to pi sine of mod x dx, comma, where within the two single vertical bars dot, that is some function, in place of dot some function, is a modulus function. No, it is a given integral. First of all, this integral is along with the limits. Whenever integral is given along with the limits, first we should check the limits are in the form of minus a to plus a or not. Same numbers, opposite sign, then the integral limits are minus a to plus a. Minus a to plus a, then we check the function is even function or odd function. But here, opposite sign is there, but not same limits. This is pi by 2, this is pi. So we never check the function is even or odd. Whenever these two are same opposite sign, then only we should check the function is even or odd. Otherwise, we cannot check the function is even or odd. Let I equal to integral minus pi by 2 to pi sine of mod x dx. Okay, evaluate this integral. Already we know the integral of sine x. Integral of sine x dx equal to minus cos x. So we have this integral formula only for sine x, not for sine of mod x only. We don't have the integral of sine of mod x formula. If we don't have this, then we can use this formula when modulus is eliminated only. So if you want to integrate this, first of all, this modulus should be eliminated only. To eliminate this modulus, if we can remove this modulus, then we can integrate this function only. So directly we cannot integrate sine of this mod x only. First, we should remove this modulus. Already we have done the problems on limits, continuity, differentiability. In the limits topic, we have seen the three methods for the evaluation of limits only. One method is definition method or left-right method, actual method only. LHL equal to RHL only. Second method is direct substitution. Third method is indeterminate forms only. Right? In three ways, we can evaluate the limits only, depending on the problem only. We can do the problem by definition method, that is LHL equal to RHL method, or direct substitution, or by using indeterminate form methods only. In general, we apply the definition method or LHL equal to RHL method, LHL equal to RHL method, when function contains modulus function, step function, function becomes infinite, or function is given in more than one interval, a condition is given for x in the function. In these cases, we should do the problem by definition method only, or some LHL equal to RHL method, basic definition method only, no other method only. Like that, same thing for here also. This method is for same thing for these functions, same method for continuity, differentiability, and also integrability also. Here also, we do this problem by definition method. That is, we use the definition of mod x, and then we remove the modulus. After removing the modulus, we can do the problem. Already we know the modulus function definition. We have written this in very first subtopic, limits. We know that this mod x function changes at x equal to 0. This mod x function changes at x equal to 0 only. After 0, the mod x is plus x. Before 0, mod x is minus x only. So this mod x changes at x equal to 0. That is why we check that 0 is inside the interval, outside the interval only. This mod x value changes at x equal to 0. That is why we have to check that x equal to 0 lies inside the interval, outside the interval. Suppose x equal to 0 lies inside the interval, then we should break the interval, and then we should write the integral as sum of two integrals, so that we can remove the modulus only. But x equal to 0 is inside the interval only. That is why we should break the integral, and we should write the integral as sum of two integrals only. Then I equal to integral minus pi by 2 to 0 plus integral pi to, sorry, this is 0 to pi sine of mod x dx. Here sine of mod x dx, which implies I equal to integral minus pi by 2 to 0. Before 0, this interval is minus pi by 2 comma 0. That is before 0. In this interval, mod x is minus x for x less than 0. Next, mod x equal to plus x for x greater than or equal to 0. So here, before 0, for negative values, sine x is here sine. In place of modulus, we write the minus x only. That is sine of minus x. Modulus is removed only. Plus integral 0 to pi sine of mod x. But after 0 and after 0, for all positive values of x, sine x is, that is mod sine x is, here mod x equal to plus x only, then sine x only, plus sine x here. Modulus is removed, we can integrate directly only, because we have the integral of this, integral of this. First of all, sine of minus x is minus sine x only. So this minus comes out, and integral of sine x is minus cos x. I equal to sine of minus x is plus or minus, check it out. But here sine of minus theta is minus sine theta only. That is why I'm writing this minus outside. And after writing this minus outside, we write the integral of sine. Integral of sine is minus cos x only. So that minus minus becomes here plus only. That I'm writing the plus. So integral of this is cos x minus pi by 2 to 0 plus integral of sine is minus cos x 0 to pi. From sine of minus x, we are getting 1 minus, and from the integral of sine, we are getting 1 more minus. Minus minus becomes plus. This is a function. Therefore, I equal to cos 0, 1 minus cos pi by 2, 0 plus. With this minus sign, first we substitute lower limit and then upper limit, or we write the minus of minus. But with the minus sign, according to first property of definite integral, I am substituting first lower limit and then upper limit only. So cos 0, 1, cos pi minus of minus. Cos pi is minus 1. Minus minus plus 2 plus 1, 3. If it is only sin x, directly we can integrate. If it is sin of mod x, we cannot integrate directly on it. That is why we use the definition of sin modulus. We use the definition of mod x, and then we write the sin of modulus function. Right? It is a first problem. Next, problem number 2. The value of the integral integral 0 to 4 within the brackets, sorry, inside the integral square brackets, inside the square brackets x dx, comma, where is a step function, comma, is bracket function or step function, greatest integer function. So like previous problem here, the function is contain the step function or bracket function. Because of the bracket function directly, we don't have the integral of this one. We should eliminate this bracket and then we can evaluate the integral. So to eliminate this bracket, we use the definition of step function. Already we have written the definition of step function in the very first class of the first subtopic, mean value theorems, while doing the problems on limits. So in the limits, we have written the definition of this. Mod x function changes at x equal to 0. Like that, the step function changes at x equal at every integer only. The step function changes at every integer only. We know that step x equal to 0 less than or equal to x less than 1, 1 less than or equal to x less than 2, 2 less than or equal to x less than 3, and so on. Minus 1 less than or equal to x less than 0, minus 2 less than or equal to x less than minus 1, and so on, I guess. Now in this interval 0 to 1, the function is 0. For 1 to 2 interval function is 1. For 2 to 3 interval function is 2. Minus 1 to 0 function is minus 1. Minus 2 to minus 1 function is minus 2, and so on. For every interval, left end point is the output of the function only. But here we require the 0 to 4. This function changes, this function value changes at every integer. So our interval is 0 to 4, means in this interval, at every integer, break the interval and add the integral as sum of many integrals, so that we can remove this step and we write the function. After that, we can evaluate. Let I equal to integral 0 to 4 step of x dx. Then I equal to, after 0, next integer is 1. So break this interval at 1 of step x dx, plus after 1, next integer is 2. 2 is inside the interval. So 1 to 2 step x dx, plus after 2, next integer is 3. 3 is inside the interval. So at that point, break the interval. 2 to 3 step x dx, plus next after 3, next integer is 4. Our upper limit is also 4 for the main integral. So we stop here. 3 to 4 dx. Like this, we break the interval and then we write the integral as sum of many integrals only. Because this step function changes at every integer only. So 0 to 1, we write this function. 1 to 2, we can write this function. 2 to 3, we can write this function. 3 to 4, we can write this function. And then we can evaluate. Which implies I equal to integral 0 to 1. For 0 to 1 interval, the function is 0. Plus 1 to 2 interval, the step function is 1. Plus 2 to 3, step function is 2. Plus 3 to 4 interval, step function is 3 dx. The step is removed. We know the function, we can integrate directly on, which implies I equal to 0 plus x from 1 to 2 plus 2 into x from 2 to 3 plus 3 into x from 3 to 4. Therefore, I equal to 0 plus 1 plus 2 plus 3 equal to 6. If we have modulus or if we have step, directly we cannot integrate. We have to remove the modulus. The function contains modulus, or if the function contains step function, you have to remove the step by using definition. Like this, we can evaluate this. Next, problem number 3. The value of the integral 1 to 1.5 x into is comma where in the square brackets some function is a step function or bracket function. Like previous one, again this function is actually here the function f of x equal to x into step of x square. Again the function f of x is involving the step function. Because of step function, again we cannot integrate directly. So if you want to integrate this, we should eliminate that step on it. If you remove that bracket so that we can integrate it after getting the function. Just like previous problem. But when you observe the previous and this problem, in the previous problem directly the function f of x equal to step of x only. But here the function f of x equal to x into step of x square. It is not just step of x only. It is not a bracket function just x only. It is some other function. In place of x, we have some other function. So for this, also we use the same definition, but we are the for x square the function only. Our interval is 1 to 1.5. Sorry, let us take this 0 to 1. Let us take the integral limits as 0 to 1.5 only, not 1 to 1.5, just to make this correction. Now, step of x square equal to, we start from 0 because we require the 0 onwards only, because lower limit is 0, starting from 0 only. Already we know that step of x equal to 0 when x belongs to 0, when x belongs to 0 to 1 interval. 1, step x is 1 when x belongs to 1 less than or equal to x less than 2. Next 2 less than or equal to x less than 3, and so on like this on. It is a main definition. But we require a step of x square only. Again, similar to this, we write this only. What are the function is here? X is in place of x. First, we should write like this one. Now, our starting interval is 0 for the integral. So we start here. 0 less than or equal to, in place of x, here what do you have here function? X square only. X square less than 1. Next, 1 less than or equal to x square less than 2 only. 2 less than or equal to x square less than 3. 3 less than or equal to x square less than 4, and so on like this. Now, we write the function. Just like step x only. Step of x equal to 0 when x belongs to this interval only. Like that. Step of x square equal to 0 when x square belongs to 0 to 1. Step of x square equal to 1 when x square belongs to 1 to 2 only. For 2 to 3 interval, step of x square is 2. For 3 to 4 interval, the step of x square equal to 3, and so on like this, and so on. For this step x only. But here the variable of integral is x only. So we require the x limits only. When x square lies between 0 and 1, x lies between, which x lies between two values only. We find out that x. Or to find the x limits, we should get here x only. Instead of x square, we should get x. So we should add the x only. To get x here, take the square root. If we take the square root for each and every term, then we get the x only. So that we can add the x limits directly on. Or 0 root less than or equal to this x square root less than square root 1, or square root 1 less than or equal to root of x square less than square root of 2, or root of 2 less than or equal to square root of x square less than square root of 3, or square root of 3 less than or equal to square root of x square less than square root of 4, and so on like this. Just like this. So that directly we get the x, and then we can add the x limits. Or root of 0 is 0. 0 less than or equal to root of x square is x. X less than 1. Or 1 less than or equal to x less than root 2. Or root 2 less than or equal to x less than root 3. Or root 3 less than or equal to x less than root 4. Root 4 is 2 on, and so on like this. But our upper limit of the given integral is 1.5 only. So we start at 0 and we add the integral sum of integrals up to 1.5 only. Let I equal to integral 0 to 1.5 x into step of x square dx. Then I equal to, now we should write this step x square depending on this function only, right? But this function step of x square changes the value at these points on the step of x square, because 0 less than or equal to x square less than 1, it is also same as the 0 less than or equal to x less than 1 only. So this or this or this only. Step of x square value changes at these points 1, root 2, root 3, 2, and so on like this only, right? So after 0, we break the it to 1. Integral 0 to 1 plus 1 to root 2. Root 2 is 1.414, but our upper limit is 1.5, so we cannot stop here. Here 1 to root 2 plus next root 2 to root 2 to 1.5. Root 2 to 1.5, right? for 0 to 1. For 0 to 1 interval, what is the step of x square function? 0. X into 0 dx. Next, x into, for 1 to root 2. 1 to root 2, the same as the function is 1 dx. Root 2 to 1.5. That is after root 2. After root 2, before root 3, the function is 2 only. So x into 2 dx. Step is removed. Now we can integrate on, which implies I equal to integral of this is 0 plus x square by 2 from 1 to root 2 plus integral of x is x square by 2, 2 to get cancelled, x square from root 2 to 1.5 equal to, for upper limit, this 1 by 2, upper limit, this becomes 2, because x square root 2 square is 2 minus 1 plus, for upper limit, 1.5 square minus root 2 square, that is 2. This is 1 by 2. Therefore, I equal to 0.05 plus 1.5 square minus 2 point something equal to 0.75. It is a value. Already we know that step of x square function, step of function here, that is we have written the step of x square function. Based on this, we are writing the integral sum of many integrals, and then we can evaluate like this one. Right? It is a value of this one. So for this, writing the step of x square function, we should know the step of x1. That is a main function, base function. Based on that step of x, we are writing this function like this one. Okay. Okay. This is the third problem. Next, we are going to next problem, problem number 4. The value of integral 0 to pi x into sine power 8 of x into cos power 6 of x dx is the value of the integral. Limits are not in the form of minus a to plus a, so we need not to check the function is even odd. And also, this whole function is not involving any modulus function, step function, and it is not becoming infinite, and no condition for x in this integral problem. So directly we can evaluate by method. If we have only integral of sine, we can integrate. If we have integral of x power something, we can integrate it. Integral of cos, we can integrate. Integral of something, whole power something, we can integrate on it. Integral of x, we can integrate. Integral of x square, we can integrate. Suppose if we have integral of product of 2 function, we can use the integration by parts formula and we can evaluate. But here it is a integral of product of 3 functions. 1, 2, 3. 3 functions. If we have a product of 3 functions, directly we cannot evaluate. If it is reducible to product of 2 functions, we can integrate on it. If we can reduce the product of 3 to product of 2 functions, we can integrate on. Out of 3 functions, one of the functions just x only, x into sine power 8, cos power 6 only. If you take this function as f of x, the whole integrand function will be in the form of x into f of x only. If you consider these two together as f of x, other variable is x, then the whole function will be like this, x into f of x. That is, if any function f of x is multiplied with the variable x, then we can reduce this product to single function f of x with the condition f of a minus x equal to f of x only. So by taking this f of x, we verify this condition satisfies, we can apply the property number 7, right? When function is multiplied with the x. Okay, let us verify the condition by taking this as f of x. Let f of x equal to sin x power 8 into cos x power 6. Then f of a minus x. Here the integral is in the form of 0 to a form, a equal to pi. So a minus x means pi minus x equal to sine of pi minus x power 8 into cos of pi minus x power 6 equal to sine pi minus x 0 pi by 2 pi 3 pi by 2 comma 2 pi. Pi minus means before pi, that is in second quadrant. In second quadrant, sine is positive, but cos is negative only. So depending on the pi minus x, that is depending on the pi minus x means depending on the quadrant, we can add this sine. Sine of pi minus x is plus, because sine pi minus x belongs to second quadrant, and the second quadrant sine is positive only, so its sine is less. But cos pi minus x is second quadrant sine is negative, so its sine is negative. Next, depending on the pi, we write the same function or different function only. For 2 pi pi, for pi 2 pi, that is for horizontal, function doesn't change, it remains same only. For pi by 2, 3 pi by 2, function changes. Sine to cos, cos to sine, tan to cot, cot to tan, cosecant to secant, secant to cosecant. When the function of pi by 2 minus something, pi by 2 minus plus something, 3 pi by 2 plus something, 3 by 2 minus something. So for vertical, that is for pi by 2, 3 pi by 2 function changes. For pi 2 pi function doesn't change. So here sine of pi minus x means plus sine x. Depending on the quadrant, we write the sign, that is plus for sine function. And also depending on the pi, we are writing the same function. Sin x power 8 into, depending on the quadrant, it is minus, cos in second, cos is negative in the second quadrant, sin is minus. But according to this pi, cos doesn't change, it remains same. So cos x power 6. Sin x power 8 is sin x power 8 minus cos x power 6 is plus cos x power plus cos x, because this power is even integer. Because an even integer, even though it is negative, this becomes positive only. So finally, this is same as the function f of x. Here, f of a minus x equal to f of x. This condition is satisfied. Whenever this condition satisfies, we can apply the property number 7 only. Let I equal to integral 0 to pi x into sine power 8 of x into cos power 6 of x dx. Then this will be reduced to, a by 2, here a is pi, so pi by 2 into integral 0 to pi sine power 8 of x into cos power 6 of x dx, according to this property. Since integral 0 to a x into f of x dx equal to a by 2 into integral 0 to a f of x dx if f of a minus x equal to plus f of x. According to this property, we have written like this. Now, inside the integral, just product of two functions, sine and cos. The powers are 8, 6. Only integral of sine x is known, only integral of cos x is known. If we have integral of sine x into cos also, we can evaluate. But if we have an integral of sine power something like this, sine cos power something, then we try to evaluate this by using the one of the standard integral property number 9. Using the property number 9, that is integral 0 to pi by 2 sine power m cos power n, we write the value of this. To apply ninth property, here we should have integral limits as 0 to pi by 2. But integral limits are not 0 to pi by 2, 0 to pi. Because 0 to pi, we cannot evaluate by using that property only. If you want to apply ninth property, here we should have limits as 0 to pi by 2. Now, according to sixth property, if it is possible to reduce 0 to pi to 0 to pi by 2, we can reduce only. The property number 6 is like this. Integral 0 to a f of x dx. We can write the integral 0 to a as 0 to a by 2 with some condition. 2 times integral 0 to a by 2 f of x dx. If f of a minus x equal to plus f of x. 0 if f of a minus x equal to minus f of x. Like this. According to this property, we can write this, which implies I equal to pi by 2, 2 times integral 0 to pi by 2 sine power 8x into cos power 6 of x dx, which implies I equal to pi. Now we can evaluate this integral by using standard integral property number 9. It is in the form of 0 to pi by 2 sine power m cos power n only. Now using the both m and n, we get the integral value. M equal to 8, n equal to 6 only. Now let us start with the power m minus 1. Here m equal to 8. Start with m minus 1 in the numerator and decrease by 2. That is 8 minus 1 into 8 minus 3 into 8 minus 5. Like this, we can do like this. 8 should not be less than 5. It should not be same as this only. 8 should be more than this number only. Until that, we can do this. 8 minus 5, 8 minus 7. Next number will be 8 minus 9. But 8 is less than 9 only. That is why we should not write this only. So we stop 8 minus 7. Next, into start with 6 minus 1 and decrease by 2 only. 6 minus 3 into 6 minus 5. Next number is 6 minus 7. But this is less than 7. That is why we should not write this one. Stop here on in the denominator. In the denominator, we write the sum of the powers minus 1, minus 0. 8 plus 6, 14 minus 0 and decrease by 2 only. 14 minus 2 into 14 minus 4 into 14 minus 6 into 14 minus 8 into 14 minus 10 into 14 minus 12. Next one is 14 minus 14. That is not possible. Stop, because this 14 should not be same as this number and should not be less than this number. 14 should be more than next number onwards. Stop here. Into k. The k value depends on both m and n. Here m equal to 8, n equal to 6. Both are even integers. So we write the into pi by 2 only. Therefore, I equal to. If we simplify this, we can get the value of this. Now after simplification, its answer is 5 pi square divided by 4096. This is about problem number 4. Next, we do the problem number 5. Fifth problem. The value of if x into sine of pi x equal to integral 0 to x square f of t dt, comma, where f is continuous function, where f is continuous function, then f of 4 equal to it is a problem. This f is continuous function, and then f of 4 equal to. That is, we are asked to find the function value at 4. We are asked to find the function value at 4. If you know the f of x equal to something, then we can add the f of 4 by replacing x with 4, so that we can add the value on it. Here, that f of x is not given directly. That f of something is given inside the integral. Inside the integral. That the function is given inside the integral. If we can get this function f of t or f of x, then we can add the f of something value on it. So we should get the function on it. But this is inside the integral. If we can eliminate this integral, so that we can get the f of t on it. If we integrate this, we get the function. If we get function, we can get the value of this on it. So to integrate this, we differentiate on it, because derivative of integral will get cancelled, we get the function. And look at the last 2 properties in the last class only. Property number 12 and 13 only. Property number 12 and 13 only. D by dx of integral of. Next, d by dx of integral something to something function, like this. We have 2 properties like this. D by dx of integral of f of x dx. D by dx of integral of something, but here u of x to v of x only. So we have to apply the one of the property. If we don't have the integral limits, then we apply this property only. If we have an integral limits, we apply this property only. So property number 13, because here the limits are 0 to x square. Here limits, lower limit is 0, upper limit is function of x only. When both the limits are functions of x, or any one of the limit is function of x, then we should apply the last property, this property only. That is 13th property only. Right? If we don't have limits, we apply this property only. But for this integral, we have the limits, and that too, one of the limit is function of x. That is why we should apply this property only. So using this property number 13, first we try to get the function, and then we write the value of the function at a particular point 4. Given x into sine of pi x equal to integral 0 to x square f of t dt. To get f of t, we have to remove the integral. To remove this integral, we take the derivative on both sides. So differentiate both sides with respect to x, which implies d by dx of x into sine of pi x equal to d by dx of integral of 0 to x square f of t dt. Left hand side, it is a product of two functions, UV rule. X into integral of sin A, derivative sin is cos, but x quotient is pi. So pi into cos of pi x plus x derivative 1, just cos pi x equal to right hand side, we apply the property. Just like d by dx of integral u of x to v of x form only. Just we remember that property just like upper limit minus lower limit only. So d by dx of upper limit x square into, we substitute this upper limit in the function in place of t only. In place of t, write the x square minus lower limit. That is d by dx of lower limit is 0 into f of 0. Since the property is like this, d by dx of integral u of x to v of x f of x dx equal to d by dx of v of x into f of v of x minus d by dx of u of x into f of u of x, like this, just like upper limit minus lower limit formula. This is a property which implies left hand side, this is sin sin pi x. So pi x into cos of pi x plus sine of pi x equal to, now right hand side, second term is 0. After minus, this part is 0 because derivative of 0 is 0 only. Next here, d by dx of x square is 2x. 2x into f of x square. Now we got the function, unknown function f. We write the f of x square equal to pi x into cos of pi x plus sine of pi x divided by 2x. Now up to here we got the function, so that we can add the value of the function. If you know the f of x, then to get f of 4, we write the 4 in place of x only. Suppose if you know the f of x square function, to get f of 4 in place of x, we write the 2 only. But here the function is f of x square. That is, to get the f of 4, just substitute x equal to on both sides only. Therefore, f of 4 equal to, that is for x equal to 2 only. This is 2x. So this pi x means here x equal to 2 pi cos 2 pi 1 plus sine 2 pi. Sine of any integer of pi is 0 divided by 2 into 2 only, because x equal to 2 only. So 2 get cancelled. Therefore, this is pi by 2 for x equal to 2. We are getting f of 4. So this is the finding the value of the function when function is unknown or given indirectly inside the integral. This is fifth problem. Next, problem number 6. Limit extends to 0 of something by something, right? That is numerator function by denominator function. In the numerator, integral 0 to x square sine of root x dx. In the denominator, x cube equal to limit extends to 0 of something by something. The numerator is integral. In the denominator, x cube, just x cube function. Integral is 0 to x square sine of root x dx. One method is first evaluate this integral. After evaluating the integral with respect to x, we get some function. Substituting the limits, we get the function of x. That function of x divided by x cube. For total function, we can find the limit. That is one method. Or other way, take this limit in the denominator 0 directly. In the numerator, x equal to 0 means 0 to 0. Then 0 to 0 means for any integral, the limits are same. What is the function? This is always 0. So for at x equal to 0, the numerator is 0, denominator is 0. Then it is 0 by 0 form. 0 by 0 form. If it is 0 by 0, then we apply the L'Hospital rule. According to L'Hospital rule, differentiate numerator separately, differentiate denominator separately only. And then we get the function. After getting the function, we observe that function. And we check that function is also in the form of 0 by 0 or not. Not 0 by 0, we can evaluate it. That is, we write the value only. If it is 0 by 0, once again we differentiate on. Limit extends to 0 of integral 0 to x square of sine of root x dx divided by x cube. This is equal to, because of 0 by 0 form, we differentiate numerator separately, denominator separately. That is d by dx of something, d by dx of something. Limit extends to 0 of derivative of numerator. That is, we write the d by dx of integral 0 to x square sine of root x dx. In the denominator, d by dx of x cube only. That is, we are differentiating numerator and denominator only, according to L'Hospital method. By LH rule, L'Hospital rule only, because of 0 by 0 form, equal to limit extends to 0 of, just observe the numerator. The numerator is in the form of d by dx of integral function of x to function of x sine function dx only. So to differentiate this integral, we use a property number 13, just like previous problem only. So d by dx of upper limit x square, and we substitute x square in the function sine in place of x. That is sine of root of x square minus lower limit is 0. Because of 0, derivative of 0 is 0. Or we can write in the denominator, derivative of x cube is 3x square. This is equal to limit extends to 0. This is 2x into sine of x square, root of x square is just sine x. Sine x in the denominator 3x square only. Again here it is 0 by 0 form. Because of 0 by 0 form, once again we differentiate and we write the limit only. Or we can use one of the standard limit. After cancelling the x with this power, we get the sine x by x only. As x tends to 0, sine x by x is 1. Because of this 1, directly we write the value, that is 2 by 3 only. Since limit extends to 0 of sine x by x equal to 1 only. After cancelling this power and with this x, we can get function as sine x by x only. As x tends to 0, sine x by x is 1. It is a value. So this problem is involving both the limit and integral. That too, the limit is indeterminate form only, 0 by 0 form. Next, problem number 7. The value of integral 0 to pi integral 0 to pi by 4 of inside the integral, the function is sine 2x divided by cos power 4 of x plus sine power 4 of x dx is the value of integral. The value of integral 0 to pi by 4 sine 2x divided by cos power 4 plus sine power 4. Just by looking this function, if you are able to identify the method, you can identify. Just by looking at the function, if you are unable to identify the method, look at the any substitution method. Look at the function, check the substitution method works or not. Substitution method doesn't work, then we try for simplification. After simplifying this, can you do the problem or not? We check it out. All functions are given in terms of sine and cos only. If you can express in terms of cot or in terms of tan, also we check whether we can evaluate or not. In the denominator, if you take the cos outside, if you take the cos as common, then this becomes 1 plus sine by cos, that becomes tan. Or if you take the sine as common, that is sine power as common, then it becomes the cos by sine as cot plus something, that is 1. Like that, by taking this outside, we can get in terms of tan, so that we can express the total function in terms of sine and we can express the total function in terms of sine and cos as in terms of tan and secant, like this. And possible to evaluate, we can evaluate them. So we try for this by taking the cos power 4x as common, or by taking this outside, we write the 1 plus something. Let I equal to integral 0 to pi by 4 sine 2x. In the denominator, we take the cos outside. We take the cos outside. Cos power 4x in the denominator. Cos power 4x is outside. Inside the brackets, 1 plus sine by cos. Sine power 4 by cos power 4. That becomes tan. Like this. This is equal to integral 0 to pi by 4. Now we can write this sine 2x as 2 sine x into cos x. Because already we have the cos power 4 in the denominator. That's it. To cancel the cos, we are writing the sine 2x as 2 sine x into cos x. Cos power 4x into 1 plus tan power 4 of x dx. Then I equal to integral 0 to pi by 4. One numerator cos, one denominator cos, both will get cancelled. Here in the denominator, cos cube remains. We write the cos cube as cos into cos square. So one sine, one cos together, tan. From the numerator sine, from the denominator cos, both together tan. So 2 tan x. We are taking the one cos from the denominator, and by taking the sine cos together, we write the sine tan. And other cos of numerator will get cancelled with the denominator cos, and cos square remains here. So 1 by cos square becomes secant square. Next, in the denominator, 1 plus tan power 4. I'm writing the tan power 4 as tan square x whole power 2, like this. Suppose if we take the tan square, take the tan square x equal to t, then the derivative of tan square is 2 tan x into tan x derivative secant square. So here we have the 2 tan x into secant square. We can write the differential. We can use the substitution method. put tan square x equal to t, which implies 2 tan x into tan x derivative secant square dx equal to dt. When you are changing one variable to some other variable, you have to change the limits, or without changing the limits also, later we can change. First, we evaluate the problem in terms of t. After evaluating the function in terms of t, we get function of t. After getting the function of t, again we convert the function of t to function of x, and we can substitute the same limits, or we can change the limits also. Let us change the limits. Tan square x equal to t. The lower limit for x equal to 0, upper limit for x is pi by 4. When you substitute x equal to 0, what about the 0? If x equal to 0, tan 0, 0, t equal to 0 only. X equal to pi by 4, tan pi by 4 is 1, its square is also 1, so t equal to 1. As x varies from 0 to pi by 4, t will vary from 0 to 1 only. So we substitute all these in the integral. Now I equal to integral 0 to 1, 2 tan x secant square x dx is dt divided by 1 plus. In place of tan square, we are writing the t. This becomes t square. So 1 plus t square. Finally, this integral is in the form of very simple integral, that is standard integral. It is in the form of integral of 1 by 1 plus x square form, or 1 by a square plus x square form only. So this is equal to tan inverse of t from 0 to 1. Therefore, I equal to upper limit tan inverse of 1 minus tan inverse of 0 equal to tan inverse of 1. This is possible for theta equal to pi by 4. And tan inverse of 0 is 0. X1 is pi by 4. Because tan pi by 4 is 1, then pi by 4 is tan inverse of 1. So directly substitution method doesn't work, but indirectly substitution method works only after simplification like this. So these are the problems on definite integrals. So with this problem, the problems on definite integral are completed. So this definite integral topic is completed. Next, it's continuation. After this topic, next continuation topic is improper integrals. Improper integrals. So we start the next topic, improper integrals. According to get syllabus, main first topic is mean value theorems. Next one is Taylor-Maclaurin series. Next, partial and total derivatives. Next, maxima and minima. Next, definite integrals. And the sixth one is improper integrals. According to get syllabus, there is one. According to IS syllabus, limits connote differentiability in the problems on indeterminate forms. So next topic is improper integrals. Improper integrals. Actually, previous and this type both together only one topic only, but with some condition we are separating these. Some condition we are separating like this. Improper integrals. Now, first we'll discuss about what is the meaning of improper integral. Already we know that it is an integral. It is also integral, no difference. Suppose if I write the like this. We have a difference between these two integrals. Both are integrals only. First one is integral without limits. Second one is integral with limits only. With the limits. Integral with the limits is definite integral. This is the definite integral. This is indefinite integral. The first integral is indefinite integral. Second one is definite integrals only. Right? Indefinite, definite. Because here it will have a unique value. It will have a unique value. Here, if we integrate this will give the function. This integral will give the function. This integral will give the unique value. This is value only. Now, up here we know that integral a to b f of x dx. This is the definite integral. Again, the definite integrals are two types. One is proper integral. Other one is improper integral. Based on function f of x and the limits a and b only. Based on limits and function, we have two types of definite integrals. So definite integrals are two types. Definite integrals are two types. One is proper, other one is improper. The proper or improper depends on the function f of x and the limits only. Whenever the function has finite value, the function has finite value in the interval. Function has finite value for all the values of x inside the interval. And a, b are finite. That is, limits are finite, function is finite. Limits are finite, function is finite. Limits are finite means 1, 200, 1,000 like this only. Limits are finite, not infinity, not minus infinity only. So whenever the limits are finite, the function is finite, then the integral is proper integral only. Otherwise, improper. Otherwise means proper fails. Proper means what? Function is finite, limits are finite only. For all values of x inside the interval, the function value should be finite and the limits are finite, then only proper. Otherwise means infinite. So whenever function is infinite, whenever function f of x is infinite in the interval, at a or at b or in between a and b somewhere, one or more points. Next, a and b are infinite. So whenever the limits are infinite or function is infinite, then such an integral is called improper integral. Out of f of x, a and b, any one is infinite, all are infinite, then the integral is improper integral. Out of these three, any one is infinite or all are infinite or some are infinite, then the integral is improper integral. That's it. Definite integrals are two types. One is proper, other one is improper. The proper and improper depends on the function and the interval. So condition for proper is function should be finite. That is, the value of the function should be finite inside the interval, and also limits should be finite. That's all. Function should be finite, limits are finite, proper integral, otherwise improper integral. So for whatever we have done the problems, in the previous topic, all those are proper integrals. Or we can go to each problem and we can check it also. Whether the function is finite or not in the interval and the limits are finite or not, we can check it on. We did not do a single problem with the infinite limit only in the previous topic, definite integrals. That is why all those problems are proper integrals. For example, here, integral 1 to 2, 1 by x dx. Here the function is 1 by x. And the limits are 1 to 2 only. Limits are finite. The function is like this only. Check this function has finite value or not in the interval 1, 2 only. First of all, this function is something by something form. And this is not defined only at x equal to 0. That 0 is not inside the interval. So inside the interval 1 to 2, for all the values of x, this function will have finite value only. So f of x is finite, limits are finite, therefore it is proper integral only. For example, integral is like this. Integral 0 to infinity e power minus x dx. Now here, one of the limit is infinity. Directly it is improper integral. Suppose integral is like this. Integral 1 to 7, 1 by x minus 1 dx. Directly this function is not defined at x equal to 1. That 1 is inside the interval. So this is also improper integral. Or integral 1 to 7, 1 by x minus 2 dx. Limits are finite. Here limits are finite, but function is not defined at x equal to 1. Here limits are finite and the function is not defined to only 2. 2 is inside the interval. Within the interval, at one of the point 2, this function is not defined. So it is also improper integral like this. In this example, improper integral, limit is infinity. In these two, limits are finite, but function is infinite like this. Sometimes both may be infinite also. Here function is infinite at upper limit in the interval, the infinity limit, then it is also improper integral like this. So this is about proper improper. You can find these improper integrals in the Laplace transform, Fourier transform, Fourier integrals like this. Because in the Laplace transform, in the unilateral transform, in the unilateral Laplace transform, the integral limits are 0 to infinity only. Bilateral minus infinity to plus infinity only. So infinite limits only. Next, we have a Fourier integral, Fourier transform, again infinite limit. All those are improper integrals. That is why you will discuss about the region of convergence, ROC only. Because of the improper integral, you will discuss about region of convergence. So here we'll discuss about the convergence of the integral. If it is proper integral, first of all, we know that all functions may not be integrable only. If it is proper integral, function is integrable, we can add the value only. Otherwise, we cannot write value only. If we write the value of the integral of proper integral, this value is always finite. The proper integral will give finite value always. But if it is improper integral, the value of the improper integral may or may not be finite. The value of the proper integral is always finite, but the value of the improper integral may or may not be finite. That is why in the improper integral case, we check the convergence, divergence of the improper integral. That is, we check whether the given improper integral is convergent or not. So we'll discuss about the convergence of improper integrals in this topic. Okay, first we are the types of improper integrals. Just now we have seen what is the meaning of improper integral, right? Again, improper integrals of different type. Improper integrals of two types only. Mainly three types, but here we are writing only two types only. Because for convergence, the convergence of improper integral is same for two types of improper integrals out of three. That is why we write all three together, two improper integrals. Now, first we write the types of improper integral, and then we write the convergence of that. After that, we do the problems. Types of improper integrals. Now, in which the first one, first kind improper integral. Or improper integral of first kind. First kind improper integral or improper integral of first kind. If a equal to infinity or b equal to minus infinity, or both a and b are infinite, but f of x is finite in the given interval. F of x is finite in the given interval. Then the integral a to b f of x dx is called improper integral of first kind. First kind improper integral or improper integral of first kind. What is the condition for first kind improper integral? Function should be finite, but limits may be infinite. F of x is finite, any one of the limit is infinite, both are infinite. So only limits are infinite, but function is finite. That is first kind improper integral. Example, integral 0 to infinity e power minus x dx. At 0, this function will have finite value. At infinity, this will have finite value. Between 0 to infinity, between 0 and infinity, for all the values, it will give finite value. So this comes under first kind. Example number 2, integral minus infinity to 0 e power x dx. So e power x will have finite value at 0, minus infinity, between 0 and minus infinity and 0 only. For all the values, it will give finite value. So it is first kind improper integral. Example number 3, integral minus infinity to plus infinity e power minus x square dx. Because of the infinite limits, it is improper integral, and this function will have finite value at this point, between all the values of x. All these are first kind improper integrals. Next, second type. Second kind improper integral. Second kind improper integral. If both a and b are finite, that is, limits are finite, but f of x is infinite. But f of x is infinite in the given interval. Then the integral a to b f of x dx. Integral a to b f of x dx is said to be proper integral of second kind. If both a and b are finite, but f of x is infinite in the given interval, then the integral is said to be improper integral of second kind only. It is purely reversed to first kind only. In the first type or first kind, limits were infinite, function was finite. But here, limits are finite, function is infinite. It is only difference. Example, integral 1 to 4, 1 by x minus 1 dx. Example number 2, integral 1 to 4, 1 by x minus 4 dx. Example number 3, integral 1 to 4, 1 by x minus 1 into 4 minus x dx. Example number 5, integral 1 to 4, 1 by x minus 3 dx. All these are improper integrals. Directly by looking at this function, by looking at this integral, we cannot say. In the previous one, just by looking at the integral, directly we can say improper because infinite limit only. But here, limits are finite. Whenever limits are finite, these integrals may be proper or improper. That depends on the function. Limits are finite, then we should check the function. Function is finite or infinite. 1 by x minus 1 is infinite at x equal to 1. That 1 is inside the interval or at the end of the interval only. Now 1 by x minus 4, it is infinite at the upper limit only. And this function is infinite at 1 and 4. Both are end points of the interval or limits only. But this function is infinite at x equal to 3. That 3 is inside the interval. That is between 1 and 4, somewhere 3, this function is infinite. This is second kind. Third kind is all are infinite. Under first kind condition is limits are infinite, function is finite. And the second kind of function condition is limits are finite, but function is infinite. Third kind is all are infinite. Limits are infinite, function is infinite. But the method of checking the convergence of the integral of first kind, third kind is same. That is how we are considering only two types or two kinds, first kind, second kind. The method of checking the convergence of the third kind is also same as first kind. So whatever the function, doesn't matter. Whether the function is finite or infinite, doesn't matter. The limits are infinite, directly improper integral of first kind. Right? So we are considering third also under first, and then we check the convergence of improper. Convergence of improper integral. The first point. The improper integral integral a to b f of x dx equal to finite value, then improper integral is said to be convergent. That is, the value of the integral is finite. Or the integral exists. No. Already we have written this here, finite value. So we write other way. That is the integral exists only. Integral exists. So for improper integral, after evaluation, the value is finite. We can say that improper integral is convergent integral, or integral exists, or integral is possible only. The value of the different integral is finite, then we can say integral is convergent integral, or the integral exists. Next, second one. The improper integral a to b f of x dx equal to plus infinity or minus infinity. Then improper integral is said to be divergent. The integral is said to be divergent or not convergent only. That is, the integral does not exist. Integral does not exist. Like this, we can check the given improper integral is convergent or divergent just by evaluating the integral. After evaluation, we get some value. That value is finite or not. Check it only. Finite, convergent, or integral exists. Infinite, then integral is divergent or not convergent, or integral does not exist. Right? Okay. We do the problems on this. Problem number 1. The integral 0 to infinity sin hx dx. Option A converges to 1 by 3. Option B converges to minus 1. C converges to 0. Option D, the integral diverges. So we can check this integral is convergent or not after the evaluation of the integral. So we are given integral along with the limits. Whenever the integral is given along with the limits, then this will be definite integral. If it is definite integral, the definite integral may be proper or improper. That depends on the function and limits. But in this given definite integral, one of the limit is infinity. Because of infinite limit, directly it is improper integral of first kind. Infinite limit, improper integral. And again, in the improper integral, we have different types or for different kinds only. So because of infinite limit, this comes under first kind only. So given integral is a improper integral of first kind. Now before doing this problem, first you have to discuss the method of evaluation of improper integral. Now look at this. Or we go to next page. We'll discuss. Integral 0 to infinity f of x dx. Integral minus infinity to 0 f of x dx. Then integral minus infinity to plus infinity f of x dx. All these are first kind improper integral. Third also, we infinite limit, what are the function doesn't matter. Directly we consider the first and third together only one kind only. Now we'll discuss the method of evaluation. In the first improper integral, only one of the limit is infinity only. In the second improper integral, only lower limit is infinity. In the third integral, both limits are infinite only. Only one of the limit is infinity, we can go for direct integration, no special method here. Only one of the limit is infinity, we can go for direct integration. Suppose both limits are infinite, we should not integrate directly only. Here we have some method of evaluation. The method is like this. If the limits, or if both limits A and B are infinite like this, then we should write this integral as a sum of two integrals by breaking the interval into two parts. Between minus infinity and plus infinity, we should choose some value somewhere. At that point, we break the interval and write the integral as sum of two integrals. Minus infinity to A plus A to infinity like this. F of x dx, f of x dx, like this. The condition is here, minus infinity less than A less than infinity. Between minus infinity and plus infinity, somewhere we choose some point. And the condition is f of x should be finite at this chosen point. That is a condition. We can choose any point anywhere between minus infinity and plus infinity, and we write the integral as sum of two integrals like this. But the condition is, at this chosen point A, the function should be finite. That is the condition. After writing like this first integral is in the form of this second type. Not second type is not second kind here. This is in the form of like this. And this is in the form of like this only. So we can do the integration here directly. We can do the integration because only one of the infinite limit. Like this. So if we have both infinite limits, we should write like this. We choose some value between minus infinity and plus infinity. We write the integral as sum of 2, and we check whether these two integrals convergent or not separately only. If this is convergent, then directly this is convergent. It is a method. Suppose this first one is given like this. Directly we can integrate and we can check the value is finite or not. Depending on that, we can set convergent or not. Second one is given like this. The integral is given like this. Directly we can evaluate, we can check. Suppose the integral is given like this, then we should do the problem in this way, like this. Okay. Next, this is for first kind improperty. Second kind also similar to this. Let us consider the example here. 0 to 1, 1 by x minus 1 dx. This function is infinite only at upper limit. Function is infinite only at one upper limit. Right? Here we can go for direct integration already. Suppose 1 to 7, 1 by x minus 7 dx equal to. Now this function is infinite. So this is now this function is infinite. This function is infinite at lower limit. We can go for direct integration. Suppose the integral is given like this: 1 to 7, 1 by x minus 1 into 7 minus x dx. Here we cannot do the integration directly only, like about 2 only. Because in this problem, the function is infinite at both limits of the interval or at both limits of the integral. Whenever function is infinite at both limits, then we should break the interval at some point and write the integral as sum of two integrals, just like this case. So between 1 and 7, somewhere choose some point. At that point, break the interval and write the integral as sum of two integrals, just like this. Integral 1 to a plus a to 7. 1 less than a less than 7. So between 1 and 7, somewhere choose some point a. At that point, break the interval and write the integral sum of two integrals only. 1 by x minus 1 into x, 7 minus x dx only. Here 1 by x minus 1, 7 minus x dx only, like this. Right? Now this is just like this is infinite at lower limit only. This is just like this only. This is just like this. So whenever the function is infinite at both limits, then break the interval and write the integral as like this. Check whether this is convergent or not. Check whether this is convergent or not. When these two are convergent, this will be convergent. Otherwise, not convergent. Just like previous one. When these two are convergent, this will be convergent. Otherwise, not convergent only. These two are convergent, this is convergent. Any one is not convergent, both are not convergent, this is not convergent only. So the convergence of this depends on these two integrals. Suppose the integral is given like this: 1 to 7, 1 by x minus 2 dx only. This function is not infinite at lower limit, not infinite at upper limit, but this is infinite at 1.2 inside the interval. Whenever the function is infinite inside the interval, at that point break the interval. 1 to 2 plus 2 to 7. 1 by x minus 2 dx. 1 by x minus 2 dx, like this. It is a method of evaluation only. So for improper integral, we have some method of evaluation like this. The function is infinite only at one of the limits, go for direct integration. Function is infinite at both limits, or function is infinite inside the interval at one of the point. Then we write the like this. It is a method of evaluation for second type. It is a method of evaluation for first type. Okay. Now let us go back to this page. It is a definite integral, and one of the limit is infinite, so it is improper integral. And for this improper integral, direct evaluation or indirect evaluation, check it only. It is first kind improper integral because of infinite limit. Direct evaluation means only one of the limit is infinity, we can go for direct integration. That is direct evaluation. Suppose both limits are infinite, we cannot do the integration directly. That is indirect method only. Indirect means we break the interval, write the integral sum of 2. Based on other 2 integrals, we can check the convergence of this main integral. Now in the given problem, only one of the limit is infinity. That is why directly we can evaluate and we can check the integral is convergent or not. So we can go for direct evaluation. Let I equal to integral 0 to infinity sine hx dx. Then I equal to integral of sine hx is cos hx. First one, it is sine hyperbolic. If you do not know this, then write the sine hx in terms exponential e power x minus e power minus x by 2 and integrate. In this way also we can integrate on. Or directly integral of sine hx is cos hx only. One of the limit is infinite. So in easy way to write the value of this function at this point upper limit, we should express this hyperbolic function in terms exponential because of infinite limit, which implies I equal to e power x plus e power minus x by 2 from 0 to infinity. E power infinity plus e power minus infinity divided by 2 minus e power 0 plus e power 0 divided by 2. 1 plus 1, 2 by 2 minus, here this is minus 1. Next, e power infinity is infinity, e power minus infinity is 0, which implies this is infinity plus 0 by 2 minus 1. So infinity minus something is infinity. So finally, evaluation is completed. At the end of evaluation, the value of the integral is infinite. Therefore, the given integral is convergent. Or we can write it converges to infinity. Therefore, the given integral is convergent and it converges. Sorry, not convergent, it is divergent. Infinite value divergent. The given integral is divergent. That is not convergent. And it diverges to infinity. Sometimes in the options it may be given like this: diverges to infinity, diverges to minus infinity only. In such case, we choose it like this. That is a problem. Next, problem number 2. The value of the integral minus infinity to 0 e power x plus e power x plus e power x dx is option A, E option B, e power minus 1, option C, e plus 1, option D, e minus 1. Exponential function is given inside the integral in the place of power x plus e power x. E power in place of exponent in place of this power position x plus e power x. This is a function. It is a definite integral because integral is given along with the limits, but one of the limit is infinity, so it is a improper integral. that to infinite limit. So it is a first kind improper integral. If it is first kind improper integral, check the integral is evaluated directly or indirectly only. If we have only one of the limit as infinite, we can go for direct integration. If we have both infinite limits, then indirect evaluation only. Now here we can do the integral directly only because of the only one infinite limit only. Let I equal to integral minus infinity to 0, we separate here e power x into e power x dx. Now evaluate and check the value is finite or not. This is e power x. Here also exponential, but in place of power position, we have one more exponential, e power x. E power x derivatives, this e power x derivatives, e power x. So this is just like f dash of x into e power f of x form. This is equal to e power f of x. Directly using this, we can have the integral of this. Or we can take the e power x equal to t also. Then I equal to e power x from minus infinity to 0. Which implies I equal to, for upper limit, e power 0 minus e power minus infinity on. E power 0 is 1, e power minus infinity is 0, e power 0. Therefore, I equal to e minus 1. E minus 1 means it is a finite value. So the given integral is convergent and it converges to e minus 1. This is problem number 2. Next, problem number 3. Third problem. The value of integral 0 to 1 x into log x dx is option A 1 by 2, option B 1 by 4, option C minus 1 by 4, option D 3 by 4. Now it is a different integral. Integral is given along with the limits, but the limits are finite limits. Whenever limits are finite, that is only one of the limit is infinite or both are infinite limit, directly improper integral, that to first kind. That is, we can answer the third also under first kind only. But here, integral limits are finite. 0, 1 are finite limits. Whenever integral limits are finite like this, 0, 1, then we should check the function is finite or infinite only. Because the improper integral depends on this function only. Infinite limit, directly improper integral. Finite limits, we cannot say directly whether it is proper or improper. That depends on the function. But here, this function becomes infinite at 0 only. Because log of 0 is not defined. Here our interval is 0, 1 only. So log is not defined at 0 only. But here, after 0, that 0.1, 0.1, it is defined only. Right. So this function is infinite at lower limit. That is why this is improper integral of second kind. If it is improper integral of second kind, direct evaluation or indirect evaluation, tell me on. If this function is infinite at both limits, then we can do the indirectly only. We can do the integral indirectly. That is indirect evaluation. But here the function is infinite only at lower limit. Only lower limit. That is why we can go for direct integration only. Right? Let I equal to integral 0 to 1 x into log x dx only. It is a product of two functions. So we can apply the UV rule. According to UV rule, we choose the first function, second function, then we evaluate. According to ILET, we choose the first and second function from left to right. E stands for exponential, T stands for trigonometric, A stands for algebraic, L stands for logarithmic, I stands for inverse function. Here we have the logarithmic function, algebraic function. We have these two only. We have log, we have algebraic. From left to right, logarithmic is first, algebraic is second function. This is U, this is V only. Or we write this as integral 0 to 1, log is first function, x is second function, like this, uv. Then apply the integration by parts formula. First function log x into integral of x is x squared by 2 from 0 to 1 minus integral 0 to 1 log's derivative is 1 by x into integral of x is x squared by 2 dx, which implies I equal to, for upper limit 1 by 2 log 1 0, this is 0 minus lower limit. At x equals 0, 0 by 2 is 0, log 0 not defined. So we write the limit extends to 0, 1 by 2 is constant, write a 1 by 2 outside, 1 by 2 into limit extends to 0, x square into log x. Substituting upper limit, lower limit is same as finding the limit of the function at that limits on minus. This power x get cancelled, x remains here. Integral of x is x squared by 2. Already 2 is there, x squared by 4 from 0 to 1. Now find the limit of this. Here, whenever log is there, this is understood as 0 power plus only. Because of log function, this is 0 power plus only. 0 to 1 interval. We are finding the right hand limit only. In this interval, right hand limit. I equal to 0 minus 1 by 2 into suppose the base is a, base is greater than 1, then log x is increasing function. As x tends to 0, right hand side, the log function is going down. So that is why it is infinity only. This is minus infinity, this is 0. Finally, it is in the form 0 into infinity only. If it is 0 into infinity, then LHospital rule. Apply the LHospital rule. According to LHospital rule, already we know the method of evaluation of this form only. Keep the log function in the numerator and shift the x squared to denominator. 1 by x squared adjustment. This is in the form of infinity by infinity form only. 0 into infinity is reduced to like this, infinity by infinity or 0 by 0 only. But we can reduce this to infinity by infinity only. 1 by 4 minus 0. Which implies I equal to 0 minus 1 by 2 into limit extends to 0. Now apply the LHospital method here. Derivative log is 1 by x. In the denominator, derivative of 1 by x square is minus 2 by x cube minus 1 by 4. 1 by x will get cancelled with this. Then it is not 0 by 0 4, not infinity by infinity. Directly we can evaluate. This value is 0. Therefore, I equal to 0 minus 1 by 4. This is equal to minus 1 by 4. So value of the integer is finite. Therefore, it is convergent. Convergent and also converges to minus 1 by 4. Okay. With this problem, I stop the class, today's class. That is, I close the today's session. Tomorrow we continue this. We do some more problems and then we start the multiple integral topic in the next class. That is tomorrow's class. So I'm closing this session here and we go to the doubt session class. If you have doubts, then you can ask. Otherwise, we can take rest for next class, till next class. Hello? 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 Hello?
Hello.
Tell me.
Yes, sir. So in last question, why haven't you used that u into v method? Like you said, like one of the term is polynomial, then we can use u v1 minus u dash v2 like that.
The condition is the first function should be polynomial only.
Yes, sir.
What is the first function here? According to Eilert, log x is the first function, but log is not a polynomial function.
Okay, according to Eilert, we have to check that the function.
Yeah.
So, and means why are we saying improper here? Why improper is used? Improper integral. Why we are using this?
This one, or you are talking about generally improper integral?
So in general.
In general. Now, whenever function is finite in the interval and the limits are finite, directly we can get the finite value, convergent only. That is always convergent. The function is finite in the interval, the limits are finite, that is proper integral. And the value of that is, suppose the function is integrable, we can add the value. That value is always finite only. In the case of proper integral, value is always finite. So every
Yes.
proper integral is always convergent. If it is improper integral, then the value of the integral may or may not be finite. Okay, may or may not be finite. Suppose the improper integral value is finite, then directly it is convergent only. But if it is infinite, then not convergent. That is why we discuss about the convergence of the improper integral. That is the importance of improper.
So it means that if an integral will have some point or value where it will converge, means where it will come infinity, then that integral is called improper.
Yeah, integral is integral value. Based on the integral value, we are saying that convergent or divergent. The integral value is infinite means that we can say the integral does not exist. That is, the integral will not give finite value only. It is not a bounded area. Indirectly, is geometrically it is an area only.
Yes, sir.
Unbounded area. It is
So,
not a,
so like in this 0 to infinity e to the power minus x, in no term, this term will be infinite.
0 to infinity e power
Minus x.
minus x.
Yeah.
No, here the function is finite, but one of the limit is infinite.
So, but that on that infinite limit also it will be finite now. 0.
No. What I'm saying, the proper or improper, that depends on the limits and function. Here function is finite in the interval, but one of the limit is infinity. Based on the limits and function, we are saying that the integral is proper or improper only. Function has finite value, limits are finite, then only the proper integral. Otherwise improper.
Okay. So, and one more doubt means like
value of the integral. Based on the value of the integral, we are saying that convergent or divergent only.
yes, that I understood. Okay. So you said like there is one formula limit x tends to 0 sin x by x is equal to 1.
Yeah.
Is there any formula for limit x tends to infinity sin x by x?
Limit extends to infinity.
Sin x by x.
Here, sine of infinity. First of all, sin x lies between minus 1 and plus 1 only.
Yes, sir.
Sine of anything lies between these two only. Okay.
Yes, sir.
Next, sine infinity. This is something that is finite value into 1 by infinity.
Okay.
0. 0 into something 0. It is 1 by x is not there, only sin x. So limit does not exist in the case.
So why limit does not exist?
Limit extends to infinity, only sin x. Limit does not exist. What is the meaning of limit? Limit means whatever the value of x approaches this infinity, sine function should approach to some unique value.
Yes, sir.
So, but here sine is not approaching to unique value. As x increases, the graph of the sine function is like this one. It lies between minus 1 plus 1. As x increases indefinitely like this, the sine is oscillating, not tending to a particular value only, not stopping. It is continuously moving like this. That's the limit does not exist for this case. Sin x by x means limit exists. That is 0 only.
No doubt, sir.
Is it clear?
Yes, sir. Yes, sir. Okay, sir. That's it. Thank you.
That's it.
Yes, sir.
Next. Hello.
Hello.
Tell me.
Good evening, sir.
Good evening.
Sir, page number 56, sir.
56. Yeah. Okay. Ask me.
Sir, here I step, sir, means second line of the solution.
Solution. This one. Yes, you're asking about this one?
Second line. Yes, sir. Yes,
Ah.
sir. Yes, sir.
What is your doubt? How we are getting like this?
Get how means.
Just
Yes,
we
sir,
go
yes.
back to the previous problem. In this problem, we have applied this result. D by dx of integral function of x to function of x.
Sir, yes, sir.
This one only. Just like this previous one. Right?
Okay.
Same thing.
Okay, sir. Got it, sir. Got it. Sir,
Any doubt?
but what is the actually difference between convergence and divergence, sir?
Convergent means its value approaching to finite only. Infinite means diverging. Diverging means it is not tending to unique, not tending to a particular value. It is moving other sides.
Okay, so if
Suppose bounded. Bounded means what? It bounds some area, finite area. Unbounded means infinite.
then,
Hello?
okay, sir. Okay. Yes, sir. Got it, sir.
Any other doubt?
That's it. Thank you.
Next. Hello?
Yes, sir. Good evening, sir.
Good evening.
Sir, actually, can you go to page 66, sir?
Page number 66.
Yes, sir. Sir, I have a general question, sir, in 66, sir. Sir, it is log x, it is base e or base 10, sir?
Whenever base is not mentioned here, it is understood that base e.
Base e.
Actually, we should write ln.
Yes, sir.
Instead of writing the ln, usually we write the log. And I am not mentioning the base only. Whenever I do not mention the base means, then it should be base e.
Why, sir? By default, you always assume log base e, sir?
No. It is already in the problem itself given that log x only.
Yes, sir.
Right? Base is not mentioned. So it is understood that log of x to the base e only.
And in any case, sir, by default, we have to assume log base e only. No?
Depending on the function. Suppose if you are asked to find it like this, d by dx of log x,
Yes, sir.
the base 2 only.
Yes, sir.
Suppose if you want to find the derivative of this log x to the base 2, we don't have any formula. Actually, we have the formula only for d by dx of log x to the base e only.
Base e only, sir.
So we cannot apply this formula for this function directly only.
Sir, then what is the approach, sir?
If you want to find the derivative of this function, we should express this as base e only. So we write the d by dx of log x divided by log 2 like this.
Okay, sir. It is for any base, that is log base 10, log base 5.
Anything only. Because we have the formula only for base e only.
And it is also so for same for integration, sir.
Same thing.
And one general doubt, sir, if any did not specify that we have to find a log 2, suppose. So we have to find log base of 2, log base of 10 2 or log base of e2, sir, in any general by default.
By default means it is that given depending on the given function only. Suppose if you ask to find the log x like some value of x only, and
Yes,
base
sir.
e only. Base is not mentioned, so base e only.
So by default in any subject, if it is nothing is mentioned, we have to take log base e.
Yeah.
Oh, is there a specific reason, sir, why you have to always taking base log e?
No. That depends on the given function. Naturally, we use the natural logarithm for theoretically we use the natural logarithm. For
Yes,
problematic, we use the common logarithm.
For what, guys, sir? Problematic. That means a problematic means, sir?
No, actually theoretical calculations. For theoretical calculations, we always discuss about only natural algorithms only.
Okay, sir.
Based on the requirement, we can consider the log of something to the base, depending on the function and depending on the requirement only.
So in critical calculation, log base C only.
No, it is understood. It doesn't mean that the critical calculations,
Yes, sir.
it depends on the given function only.
Also, always by default log base C we have to take.
Yeah.
Nothing.
Not mentioned means basic. That's it.
Okay, sir. And in case of differentiation integration, then we have to take this procedure follow.
First, you have to observe that whenever log function is given, in place of base, something is given or not, check it only. Base, in place of some base, nothing is given, then blindly we can follow the derivative formula, integral formula.
Okay, if nothing is given.
Suppose the function is given like this, log x to the base 2, directly we cannot write the 1 by x only.
Okay, sir. I have, sir, got this doubt because if we get log base of 5x, then it will be log x by log 5 then.
Yeah.
And in case of log base 10, log x by log 10. Okay, sir.
No.
Okay, sir. But sir, hello, sir.
Tell me.
If it is log base of 10x, then it will be log x, no, ultimately. It will convert log base C.
Log x to the base 10, you're asking
Base
about.
10, yes, sir. It will be log base of ex, no, by default, in this case.
Log x by log 10.
Log 10. Then it will be log of 10 equal to 1, then it is log of base ex, no, sir, in this case.
No. We are converting log x by log 10 means it is here base is base e, log 10 base e.
Okay, sir. Okay, sir. Log that means it is converted log base of e.
Yeah.
Okay, sir. Okay, sir. Thank you, sir.
Hello.
Good evening, sir.
Good evening. Tell me.
Sir, how area under odd signal is 0, sir?
Area under
Odd signal.
odd signal.
Odd function is 0.
Actually, area is not 0. The meaning of that is, suppose the area is like, suppose the graph is like this one. Let us suppose this is sine function. What is the graph of this? It is a graph of the sine function.
Sine.
Okay. Sine is odd function or even function?
Sine is odd, sir.
Odd function. Okay. 0. Let us suppose this pi by 2. This is pi. And it is also symmetric about this x-axis only. Whatever you get the area here, same we get the same area here also. The area of this is same as area of this. Correct or not?
Yes, sir.
This area is lying above x-axis. This is positive. It is also same area, but negative. Area is same, but this is positive, here negative only. When you add both, that will become 0 only. It doesn't mean that area is not 0.
But the limits are different now, sir.
Well, limits are different. Here, area means we should take like this modulus. That depends on the interval only. 0 to pi by 2, area is this only. Pi by 2 pi, area is this only. When
Yes,
you
sir.
add both, we get the 0 only. That is, it is saying that the area of this is same as the area of this in this interval only.
Okay, that doesn't mean it will be 0, sir.
Right.
Okay. Because in some problems, directly if it is odd signal, some sirs have took 0, sir, answer.
Geometrically, actually, different interval gives the area geometrically.
Okay.
So he's saying that geometrically, he's saying that the area is 0 means whatever you get the area above the x-axis, whatever you get the area below the x-axis, both will be same. The meaning of that.
Okay, sir. Sir, one more doubt, sir. Sir, in last problem, sir,
This one.
Yes, sir. Sir, here I have not understood that third step, sir. Actually, log 0 value does not exist, right, sir?
Yeah.
Then also you took 0, sir, answer.
No, not like that. You see this side. Actually, our interval is 0 to 1.
Okay, sir.
When it is 0 to 1, and substituting upper limit, lower limit is same as find the limit of the function only. So we have to apply the lower limit. Lower limit is same as here, like this, right hand limit only. Limit extends to 0 means if you are given interval 0 to 1, we can approach 0 only from right hand side. That is why it is understood as 0 power plus only.
Okay.
For a lower limit only.
Like you should not consider 0, sir.
Even if you consider 0 also no problem. But here it is, the meaning of this is log is here given means it is understood that only after 0 only. The function is given means.
No, sir, not that function, sir. Before that, you have took 0, sir, answer there.
Before this one, previous one, for lower limit.
Yes, sir.
No, for upper limit. Upper limit, what is here we are getting that 1 by 2 into log 1. Log 1 is 0.
Yes, that is correct, sir.
This
Next one is 0 plus we need to take.
Next one is lower limit only.
For lower limit, if we put 0, then it is indeterminate form, sir.
That is why we are evaluating the limit by using indeterminate form method.
Okay. 0 plus we will take, then we will do L'Hospital rule, sir.
Yeah. That is why we have done the problems on indeterminate forms. Indirectly, we require the indeterminate form problems for limits of the integrals also.
Okay, sir. And sir, one more thing is like in one problem you have given sine 2x by cos power 4x sine power that thing, sir. Sir, is there any other approach? Because
problem number, which definitely do you know the page number?
Page number I didn't remember, sir.
This problem?
No, sir, not this one, sir.
Okay, we go back and check one by one. This one?
No, sir.
Next, second?
No, sir.
Third?
Sir, and here, sir, before that. Yes, sir. Here, every time we need to convert in the form of x, sir.
Yeah. Because what is the integral variable here? X. So we should take the x limits. Actually, this step of x square changes the value at integer only. This is for x square function. It is also same as x means like this.
Okay, if in
for
place
x square limit, x square interval, and this is for x limit, x interval.
Okay, if in the place of x square, if they give sin x, then
same thing.
I need to
Step of sin x equal to 0, 0 less than or equal to sin x less than 1. Then you have to simplify. You have to find the x limit here.
Okay, sine inverse on both sides.
Yeah, right.
Okay, sir. And sir, that one, sir.
Next, this one.
No, sir.
Next. This one.
No, sir, not this one.
Next. This.
No, sir.
Next. This one.
Yes, sir, this one. Sir, if here, if we not get the idea, like we need to take cos power 4 outside, another method, is there anything?
No, just first we check it out. Just by looking this directly function, if we get any idea, we can do only. Do not know, if you don't have any idea, then we use the substitution method. Directly, can you go for substitution method or not? No, it doesn't work. It doesn't work means we have to simplify this, that's all.
Okay.
If
That is the approach.
If it is in terms of tan, secant, cosecant, we express in terms of sine cos. Or if it is sine in terms of cos, then we express in terms of tan or secant like this.
Okay.
We convert this into that form and we check whether that is integral or not like this. By substitution method, indirectly like this.
Okay, sir. And sir, one more last
possibilities only.
Okay, sir. Last doubt, sir. Sir, indirect integration, you said that I didn't get that.
Improper integral.
In improper indirect integration, one more.
This one, just look at this. It is a improper integral of second kind. In the second, what is the second kind condition? Limit should be finite, but function should be infinite. 1, 2, 3, 4. I wrote here 4 examples in this page.
Yes, sir.
In the first page, in the first example, this function is infinite only at upper limit.
Yes, sir.
Do the normal integration, no special method here only. Next, in the second example also, function is infinite only at lower limit. We can do the normal integration, no special method. But in the third example, the function is infinite at both limits only. That's why we cannot do the integration directly. Here we have some method of evaluation for improper integral. So in this case, between 1 and 7, somewhere we choose some point. At that point, we break the interval and we write the integral as sum of 2 like this only. And then we discuss the convergence of this integral based on the convergence of these two integrals only. When both integrals are convergent, then only this main integral will be convergent. Otherwise, not convergent. Similarly, for this also, when function is infinite between 1 and 7 somewhere, at that discontinuous point, because this function is not defined at 2, not defined means not continuous, discontinuous. At this discontinuous point between 1 and 7, break the interval and write the integral sum of two integrals and check the convergence of each only. So this is called indirect evaluation only, not direct evaluation. We cannot do the direct integration only. But in these two cases, we can do the integration directly.
Okay, sir. But in last question, we get same. We will get infinite only, sir. At the end.
Oh, wait. This one?
No, sir. No, sir. In that thing only.
Oh.
Here in the third example, we will get infinite only, sir.
Oh, no. What are the value here? This function is infinite at both limits initially.
Yes, sir.
That is why we cannot do the integration here. We have some method of evaluation of improper only. Function is infinite only at one of the limit, we can go for direct integration, normal method, no special method here. But when function is infinite at both the limits, then separate like this and then do the integration only. Based on these two, check the convergence of mean integral only.
Okay, okay. Okay, sir.
First, depending on the problem, we are writing sum of two integrals. Then we evaluate each separately. Based on the value of the integral, we can set a convergent or divergent.
Convergent, okay, sir. Got it, sir. Thank you, sir.
Hello?
Hello, good evening, sir.
Good evening. Tell me.
Sir, can you explain once again that 65F, 66F?
66.
Yeah. Why we take a limit in between integral?
No, actually, after the evaluation of the integral, we substitute
Yeah.
upper limit, lower limit, right?
Yes, sir. Yes, sir.
Substituting upper limit is same as finding the limit of the function.
Yes, sir.
That is why here, for this part, upper limit is 1. When you substitute upper limit to 1, log 1, 0 directly, this is 0 only.
Yes, sir.
When you substitute 0 here, this is defined only. But log 0 means
Not defined.
not defined only.
Yes, sir.
But here, interval is 0 to 1. When you are finding the lower limit means it is same as the finding the limit of the function right hand side only.
Okay, okay, sir.
Okay,
That's
that
why
is
we taken in the sake of solving lower limit, we simply taken limit.
no, yeah. Because we are getting indeterminate form here, 0 into infinity form only.
Yes, sir. Yes, sir.
To make it determinate, we are doing like this.
Yes, sir. So once doubt is integral 1 by x dx is log x, na sir?
Yeah.
Then whenever we solving the problems, we take log x or ln x, sir?
Log x, ln x both are same. Because if
No.
I write the log x, I won't write the base e.
Okay, why? Because in calc, I am simply calculating. That's why.
Suppose if I write the integral of 1 by x dx means
Yeah.
ln x. By default nx, but usually we write the log.
Yes, sir. If we
In case of
substitute
this, I'm not writing anything.
any values, if substitute and that's result is different. That's why I'm asking.
Base is not mentioned means it should be ln only.
Okay, okay, sir. Thank you, sir.
Hello?
Hello. Sir, 55.
55F.
Yes, sir.
Ah.
Sir, in this, the function is in t, but we are differentiating in x.
No,
And
different integral. It is a different integral. This t is a variable of integral. But to integrate this function with respect to t only.
yes, sir.
So after integrating this function of t with respect to t, we get function of t.
Yes, sir.
After that, we substitute upper limit, lower limit.
Yes, sir.
So what are the limits for t here? Lower limit is 0, upper limit is x square.
Okay.
So we are getting this.
Okay. But
That
because
is, after integrating this function, we get function of x only. Upper
okay,
limit.
okay, okay.
That is why we are differentiating both sides with respect to x.
Okay, okay. Because after integrating this function, we will get the function in x form only.
Yeah.
I was confused because, sir, in the property you have written is fx In
Yeah.
that you have written fx. That's why I was confused.
Actually, it is a definite dummy variable. This t variable is dummy. That
Okay, okay.
y anything else.
Okay, sir. Thank you, sir.
Audible, sir?
Audible.
Sir, I don't have a doubt in this. I have doubt in basis function, linear algebra.
Okay.
I didn't understand because hello.
Basis, I think. Not
Yes, sir. But because lack of time, sir did not teach well. So I just want notes of it. Do you if you do you have any recorded lecture or something notes that you can share?
I try to share the notes.
Yeah, it will be better.
Okay.
Just want the concept of that. Yes, I understood a little, but not completely. When I saw the questions, the question arises why they have means solved in this way. That is what the base is not clear for that topic.
If you are given some set of vectors, you have to check whether that set is a basis or not. Just to check it, basis or not. We use a simple shortcut method, rank method only.
Okay.
So I will send that method and also one problem on that. So we'll understand.
Means you provide procedure wise now. So
I will provide the procedure and one problem also.
yeah. Okay. I call you on that number, sir, but it's saying that only message are allowed, no call. So
I think internet problem or something is some problem is there. So we'll do one thing. You send the message to that WhatsApp.
okay.
Then I will say and I'll go through that number and then I will send the same thing to your number through that.
Okay.
WhatsApp.
Okay, sir. Thank you, sir. Thank you so much.
Today again you send it on.
Yeah, yes, sir. Yeah. Thank you, sir.
Hello.
Done, sir.
No, okay.
Thank you.
Hello. Hello.
Hello.
Tell me.
Sir, I have a doubt that there was a question of great indeed.
Which page?
So in the starting only there was one question limit 0 to 1.5 that greatest integer 1.
This one.
Yes, sir, this one. So here can we take like you said that we are converting x square to x because there is dx, right?
Yeah.
Can we convert like there is x dx now? So we can write that like 1 by 2 into dx square.
We can do this problem by substitution also. X square equal to t. X square equal to t, 2x dx equal to dt. In that way also we can do. But that method is possible only for this problem only. Other problems it doesn't work that method.
Okay, because here is x, that's why it will be.
Yeah.
Okay. So, but like that answer, I couldn't arrive to this answer.
Direct substitution method.
Okay, sir, I think I got it. I didn't change the limits.
Oh, Do not change the limits.
No,
Same thing in terms of t, in terms of x again, and now substitute same thing.
So, but afterwards, if I substitute in place of t x square, then we need not change the limits, right?
No change, no change.
Then I did that.
Okay. That's it. Any other doubt?
Good evening, sir.
Good evening. Tell me.
Sir, 49 page.
49.
This in this 18, 10 and 11.
11th property.
Yeah, I did not understand what is the difference between these two properties.
First one is UV, second one is also UV. But
yes, sir.
In easy way to do above problem, we apply the second one, generalizer integration by parts formula. But second one is applicable when the first function is polynomial function. Suppose x into sin x. We can do this by this method also.
Yes.
Instead of doing this way, directly we can write this integral value in easy way using this only. According to highlight, this x is first function, this is second function. First function is polynomial. So we can do this problem in easy way just by using this only. First function u, same function. Integral sign is minus cos x. Okay, minus first function derivative 1. Integral of second function, twice integral, that is minus sin x. Next time 0. That's all. In easy way we can write up. That is advantage. Instead of writing.
Sir, first one.
If you do same problem by first one like this, we do x into integral of sin is minus cos x minus integral derivative is 1, integral of that is minus cos x, again minus plus sin x. Once again you have to integrate one more step.
Okay, sir. Sir, in the place of u cos x,
no problem. If it is x, suppose if it is x square, x cube like this, then here very more number of steps on integral inside the integral, inside the integral on. To avoid that one, an easy way to apply this on. It's a simple method. Because it is useful for Fourier transforms, Fourier integrals, because there we can find the sine into x function of x, or cos into function of x like that.
Yes.
Okay.
Thank you.
Okay, I'm closing this doubt session also. We'll meet tomorrow.